Okay, so we're going to finish up with your worksheet here. One thing I want to point out is number 16 actually had an error. It should be MGBR2. So if you did not have that, you want to put that on there. I don't know why it did that wrong. Okay. All right, we're going to go ahead and start with balancing on number 15. We've got 1 carbon, 6 carbons. So I'm going to come over here and make this a 6. Okay. I'm going to go hydrogen next. I'm going to save the oxygens for last. So hydrogen, there's 2 on the reactant side, and there's 12 on the product side. So I'm going to come over here, put a 6. That gives me 6 times 2 is 12. Okay. All right, oxygen on the reactant side. I've got 6 times 2 is 12 plus 6. There's 18 over here. This side, there's 8. Okay. I don't want to mess with this one because if I change anything, I'm going to mess up the carbon and the hydrogen. So the 18 oxygen, I'm going to subtract 6. Okay. That gives me 12. So I can get to 12 by putting a 6 here. So let's show that again. So 6 carbon, 6 carbon. 12 hydrogen, 6 times 2 is 12, 12 hydrogen. 6 times 2 is 12 plus 6. There's 18 oxygen on the reactant side. We've got 6 plus 12 is 18 oxygen on the product side. This type of reaction I'm not going to identify for you because this is when we start dealing with like respiration, photosynthesis, biological things. So I won't ask you for the type of reaction on this one. Okay. All right, number 16, we've got 1 potassium, 1 potassium. 1 Mg, 1 Mg. We're supposed to have 2 BRs, so if you didn't fix it, so 2 BRs, 1 BR, I'm going to put a 2 here. 2 Ks, 1 K, I put a 2, everything's balanced. Now notice, there's one thing by himself and 2 things, so this is going to be single displacement or single replacement. We just have to decide if it's cation or anionic. So potassium is booting out the magnesium, and both of them are cations. Both of them are the positive ones. So this is a cationic, oops, T, maybe, cationic, and I'm just going to put SD for single displacement or single replacement. Both are acceptable. Okay, number 17 is one I'm not going to have you guys look for a reaction because it's a little bit above advanced cyanine, so we're not going to worry about a reaction on it, but we are going to balance it. So let's save hydrogen for a little bit. Let's go to chlorine. So there's 1 chlorine, 2 chlorine. Going to make this a 2. All right, 1 calcium, 1 calcium. 1 carbon, 1 carbon. 3 oxygen, 1 plus 2 is 3. We had the 2 hydrogen, 2 hydrogen were balanced. Okay, and like I said, we're not going to worry about reaction on this. All right, number 18, we've got, let's skip the hydrogen for a second. Let's go 1 nitrogen, 1 nitrogen. We've got 1 Na, 1 Na. 1 carbon, 1 carbon. Okay, we've got 3 oxygen plus 3, that's 6. We have 3 plus 1 plus 2, so there's 6. Hydrogen was the last thing. We had 2 hydrogen. We have 1 plus 1 is 2. This is a balanced equation. It is already balanced. Once again, this is one that is a reaction that's a little bit above you guys, so we're not going to worry about doing the reaction on this. All right, so number 19, we've got water and oxygen coming together to form hydrogen peroxide or dihydrogen dioxide. So we've got 2 hydrogen, 2 hydrogen. We've got 1 plus 2, there's 3 oxygen on the reactant side and 2 on the product side. So remember, the guy that's odd, we're going to double. By doubling him, okay, that gives me 4 hydrogen, 4 hydrogen. 2 oxygen plus 2 is 4, 2 times 2 is 4, we're done. Okay, so we had multiple things coming together to give me one product. So this is synthesis, but notice it was oxygen that was that reactant coming together. This is synthesis and combustion. Number 20, we have 1 Na, 1 Na, 1 Br, 2 Br. So I'm going to fix it, 2. Gives me 2 NAs, 2 NAs. 2 Fs, 2 Fs, 1 Ca, 1 Ca, we're balanced. We've got 2 things switching places. The N's going to come with the F, Ca is going to go with the Br. So this is a double displacement or double replacement. And our last one here, we've got, we'll skip the hydrogen for a second, go to the sulfates. We've got 1 sulfate, 1 sulfate. We've got 1 Na, 2 Na. Put a 2 there. Okay. That gives me 2 nitrogen, 1 nitrogen. Put a 2 there. That gives me 4 oxygen on this side, 4 oxygen. 2 hydrogen, 2 hydrogen. So make sure everything's good. 2 hydrogen, 2 hydrogen, 1 SO4, 1 SO4, 2 NAs, 2 NAs, 2 Ns, 2 Ns, 4 oxygen, 4 oxygen. Okay, so there's going to be 2 things switching places here. The hydrogen's going to go with the NO2, and the Na is going to go with the SO4, so this is a double displacement or double replacement. We will assess tomorrow over dimensional analysis, and then as soon as we get done with that, we will go through and work on some more balancing and more reaction types.